Good evening, everyone. Hello. Hope everyone is still awake that light time. All right. The evolution of AppSec, that's my topic today. And when I talk about AppSec, I'm talking about application security testing. Most probably you have heard a lot about AppSec today, but we're talking specifically about application security testing. So let me jump right into the topic, a bit of marketing. Why do I speak about that? Veracode is a quite old player in this market. We do this since 16 years. We are a 9 times Magic Quadrant leader. We have scanned 63 trillion lines of code, and our customers have fixed 73 trillion lines of flaws, 73 million flaws. Sorry for that. All right, so when we talk about the evolution of AppSec, that is pretty similar to the evolution of humans. We start in the Stone Age and we move to the present or even to the future. So we start with very manual stuff, with stones, with very heavy things to cover, and then we automate stuff. And that's what we will talk about today. I will take you to a journey through all the different solutions we have seen over time in the different areas of application security testing. I'm not boring you with more pictures, so jumping right into the topic. So, in the Stone Age, in the very early days, when we still had very large C++ applications, desktop applications, million lines of code, nobody thought about automation. We had manual code review, right? We had people hired. They came into our office and they were looking at the code. They were really reading the code our developers were writing and trying to identify if there is any security defect within that code that they have seen. A very time-consuming and a very, very expensive task. So, over time, when desktop applications moved a bit more to the internet, when we had more web applications, people thought about, well, how do we test that? How do we make sure those web applications are secure as well? So they were attacked by hackers, right? And, well, why don't we hire these hackers and try to find the flaws in our application and pay them for that? And that's how manual penetration testing was invented. We hired hackers to make sure our new web applications are secure. So these are the two major things we started 20, 25 years ago or something. When we moved a bit further, those hackers that were hired, they got lazy and they said, well, I don't want to type all that stuff anymore. I want to automate that stuff. And that's the time when dynamic application security testing actually was born, because we're, by human nature, we are lazy people, right? We want to automate our stuff. And that's why we invented dynamic application security testing, just to get this work automated. So still very early times, and we were just talking about very standard web applications. When we were moving on, some people thought about, well, those manual code reviews, they are not affordable for us anymore. We cannot spend like a month having someone in the office looking at the code and trying to identify something. That's, first of all, very expensive and a very time-consuming process. So why don't we actually do this in an automated way? Why don't we test our code in an automated way? And that's when we got static application security testing, automated code reviews. That's the reason why Veracode was founded like 16 years ago. Our founders, they were also manual code reviewers, right? They were looking at code and they were lazy and they said, well, no, I don't want to do that all the time in a manual way. And that's why they invented static application security testing and specifically binary application security testing, binary static analysis. So we just need the binary version of the application to test it, like a jar file, a DLL or something like that. All right. What do we do? What do we have today? We don't have manual code reviews anymore. We still have manual penetration testing because there are some requirements, some compliance requirements that tell you you need to do a manual penetration test, because there's one very, very specific thing that only manual penetration testers can find, and that's a business logic flaw in your application. An automated solution will never be able to identify a logic flaw in an application, because you need a human to rate the content you're looking at. So that's the important thing, why there still is manual penetration testing around, even if it's very slow and very time-consuming and very expensive. So the next thing that came up is software composition analysis. I mean, when you build applications today, when you code, you're not writing everything on your own again. Well, again, we are lazy people, right? We are all lazy. So we use libraries that do the work for us, and we implement that into our application, so we don't need to write the code anymore. And if we just think about JavaScript, Node.js, for example, developers have the possibility to choose between more than 1 million different node modules to do some tasks for us. So you can see there's really a lot that is not built on your side in your first-party code anymore. A lot is a third-party component, and a lot is just coming in from open source components. Someone has just developed, and you just don't know what's in there. So this can also bring security defects in your application, right? So you need to look at this as well. What are the known vulnerabilities here? And you most probably have heard about the new official order in the US about being able to generate SBOMs, bill of materials, for your applications. So this is playing a big role in software composition analysis here. All right, so that's what we have today mainly. But when we have a quick outlook to the future, what's coming there? And you see a lot of buzzwords here, right? IaaS, RASP, infrastructure as code scanning, Internet of Things, Docker scanning, mobile dynamic application security testing, cloud native virtual machines, and auto remediation. There's really a lot that is coming in application security testing. Why is that? Just looking at infrastructure as code scanning. A developer today is not just a developer anymore. Developers, they build Docker containers, and those Docker containers need to run somewhere. That this infrastructure is built up in an automated way. You use infrastructure as code. So you have YAML files or other text files that are creating those virtual machines for you in AWS, in Google Cloud, in Azure Cloud, or somewhere. So there can be security defects in those files as well. So maybe not creating the correct username, setting up wrong ports, and stuff like that. Another important thing here on this slide is auto remediation. We want to make this thing even more effective. And developers, well, they are also lazy and they don't want to fix all the stuff on their own anymore. So why don't we give them the possibility to automatically change their code for them, what we learn from other customers using that solution? So we help them to be more effective in actually fixing the security defects we find in their applications. That as a quick outlook here, what maybe will come. All right, so you have a lot of stuff here, right? But what do you do with all that stuff now? I mean, it's little point solutions everywhere, and that team is looking into this one, that team is looking into that one. So that's pretty complex, and you don't have any reporting that is working together. You cannot build a governance model around that. So when you look at what you need to do, we talk about a cultural change in an organization. Because to get this together, you need to have 3 teams working very closely together. Developers, security teams, and operation engineers. And that's what we call DevSecOps, right? So with the Veracode solution, we try to get all these 3 teams working together. And that's the approach on the Veracode side here. So, very important quote. what you're supposed to do when you don't like a thing is change it. If you can't change it, change the way you think about that. That's how you change culture, right? It's not just an easy thing, but you need to change the culture if you want to do application security testing the right way. All right, how do we do that? So for Veracode, application security testing is not just a technical solution. Yes, developers are very important in this process because developers are the only ones who can tell you anything about the solution. They are the only ones who can actually fix the code, right? Because they write the code and they can fix the code. So that's one part here, that's the middle part. Integrate security into the pipeline, cover all application types, and consolidate all the application security testing solutions. Have one platform, because Veracode is a SaaS-only platform, have one platform where all these scanning technologies are integrated. But on top of that, every customer is doing that a bit differently. Every customer is having a little different process, and we need to find out, what is your process? Where would you like to integrate? Would you like to do it manually? Would you like to do it on a commit basis, on a nightly build? Would you like to scan with your pull requests or merge requests into your repositories? So for that, we have our customer success managers. They help you operate an application security testing program. They know what are the best practices with the more than 2,500 customers worldwide we have. They know how to do that stuff, and they can help you integrate all that into your very specific processes. And what's also important for Veracode is we don't focus on finding flaws. We focus on fixing flaws. We don't just want to tell you, well, 1,000 findings. You do whatever you want with that, right? No, here are 1,000 findings, and we want you to fix that because that's important, right? You don't deploy that application if you know there are 1,000 findings. So also part of our service is help developers be more efficient on fixing. Not just with auto-remediation that will come in the future. There's a button on the platform. Developers can click that button and they can ask for help. They can register for a 45 minutes WebEx with one of our application security consultants and get a better understanding why that is a finding. And they also look at the source code together with the developers within a screen share and give tips on how to remediate that finding. So you see, with people, process, and technology, we try to help everyone to be able to fix as early as possible here. I just said that before very, very briefly. Veracode is a cloud-only solution. That brings a lot of advantages because we learn with every customer, we learn with every application, we learn with every single scan on the platform. So when you think about static application security testing, the first thing that comes into mind most probably is false positive rate. You most probably have heard about that already quite a lot. So in Veracode, being a cloud platform, you can specify something. This is a potential false positive. And that information will be sent to our engineers, and they will review that. If they agree, yes, that is a false positive, they will reconfigure our engine. Neither you nor any other customer will ever face this false positive again. So being a cloud platform, customers telling us what is a false positive, our false positive rate is at 1.1% as a max value. So it's very, very low compared to all the on-premise vendors out there. Also, how many applications would you like to scan? Is it one application? Well, fine. Is it 10 applications? Okay. Is it 100 applications? Well, try to do that with an on-premise solution. With Veracode, we scale to whatever amount of applications you would like to scan. On the platform, only this year, we have 7 million scans, right? So you can count how much that is per day or per minute or per second or whatever. All right, it's always up to date, it's easy to use, and with this one platform, you can build a governance model on top of everything you do in application security testing. And that's what I wanted to talk about today. Thank you for your attention. Thank you.